Myself, Professor P A Gaikwad, Assistant Professor, MPSC College Panvel, Department of Chemistry. I am teaching here the topic of coordination chemistry. It is included in inorganic chemistry paper first for SY class. So today I am discuss about what is a coordination compound and about its nomenclature, that is IUPAC nomenclature. So while naming an ionic compound, the positive ion is listed first, followed by negative ion. So here the example is CuNH36Cl3. So here that CuNH36 is a complex ion which is a positive ion. It should be named first. Then negative chloride ion, that is Cl3. Then another example is K4FeCN6, that is a potassium ferrocyanide. So here that potassium is a positive ion. So potassium is to be named first. Then complex ion, that is FeCN6. Then second rule is within the complex ion, the ligand are named first, then metal ion. Ligand are listed in alphabetical order, that is neutral ligand, negatively charged ligand, and positively charged ligand. The accepted ending for ligand are negative group ends with O. That means when we write the name of negative ligand, the name of that negative ligand is end with O. For example, Cl minus. So its name is end with O, that is chloro. Then Cn minus is cyano, NO2 minus is nitro, then CO3 minus is carbanato, then O2 minus is oxo, then C2O4 minus is oxalato. Then neutral group has no specific ending. Neutral group has no specific ending. For example, NH2. NH2 is a amine. Then CO is carbonyl. H2O is called as aqua ligand. So this is about neutral ligand or neutral group. So in case of neutral ligand, there is no specific ending. Then third type is about positive group. Positive group end with IUM. Positive group is end with IUM. For example, NO plus. NO plus is nitrocilium. Then N2H5 plus is hydrazonium. So in case of positive group, its name is end with IUM. If there are more ligand of same category, then they are named by using alphabetical order. If there are more ligand of same category, then such a ligand is named by using alphabetical order. Then third name is the prefix di, tri, tetra and hexa are used to indicate the number of identical ligand attached to the same metal center. If there are more ligand like di, tri, tetra and hexa, such a prefix are used. Then for organic ligand like dipyridine and ethylene diamine, the prefix bis, tris, tetra, kis are used instead of di, tri and tetra. That means for organic ligand, the prefix di is used in case of there are two number of organic group. Then tri are used when there are three number of organic group, and tetra are used in case of there are 4 number of organic group. Such ligand are named by using bis, tris and tetrakis. Then the name of ligand is placed in bracket. That means that name of organic group किंवा ligand is placed in a bracket. For example, PTCl6 ligand are named as hexachloro, while in COEN thrice 3 plus as tetrakris ethylene diamine. So in that two compound, that EN group is ethylene diamine and it is organic type of ligand, and therefore this ligand is placed in bracket, and 3 number is named by using tris, not tri. Then fourth type, negative complex ion end with ATE. So this is the fourth rule, negative complex ion end with ATE. In case of naming the negative complex, the name of that negative complex end with ATE, but the positive complex ion and the neutral molecule have no specific ending. But in case of positive complex ion and neutral molecule have no specific ending. For anionic complex, Latin name of the metal are commonly used. For example, stannate for SN, then aurate for AU and ferrate for Fe. Then for naming K4FeCN6, since the complex ion K4FeCN6 is a negative ion, its name end with ATE. In case of FeCN6 4 minus, its name is end with ATE, that is hexacyanoferrate. Then fifth rule is the oxidation state of central metal ion is shown by Roman numeral. The oxidation state of central metal ion is shown by Roman numeral, that is first, second, third in bracket immediately following its name. For example, CuNH342 plus named as tetraamine copper 2 ion. So that complex is named as tetraamine copper 2 ion. So here the oxidation state of copper is 2, so it is shown by Roman number 2 and it is placed in the bracket. Then sixth rule is if a ligand has more than one donor atom, then the point of attachment with the central metal is specified. If the ligand has more than one donor atom, then the point of attachment with central metal is specified. For example, SCN has two donor atom, that is S and N. Hence, it can be named as when metal atom is attached to SCN, then it is named as thiocyanate S, and M is attached to NCS, thiocyanate N. That is here attachment through S, that is sulfur group, and attachment through nitrogen is carried out, and therefore the name of that complex is carried out in different way. Then similarly, NO2 has two donor atom, that is nitrogen and oxygen. So depending upon the linkage, it is named as attachment through N as nitrito N and attachment through O as nitrito O. Then in case of geometrical isomer, naming using the prefix, that is cis or trans, or by numbering system if the structure is complicated. So for naming the geometrical isomer using prefix cis or trans, or by naming numeral system if the structure is complicated. Then eighth rule is when a complex or ligand is optically active, that is D and EL, that is desterotatory and levorotatory, refer to the direction of rotation. If the complex is optically active, the prefix precedes its name, while if ligand is optically active, the prefix precedes the name of ligand. For example, D COCl En twice Cl. So here D bis ethylene diamine dichlorocobalt 3 chloride. So this is about the naming of coordination compound. So that naming is carried out by using IUPAC nomenclature. So today we stop here. Thank you.